This is SpaceTime, Series 23, Episode 48, coming up on SpaceTime. A new plan to intercept interstellar visitors. New evidence for watery plumes erupting on Europa. And NASA's Perseverance Rover placed in launch configuration in preparation for its flight to Mars. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's providing some seed funding for a new idea to develop a fleet of prepositioned spacecraft to study visiting interstellar asteroids and comets before they zoom out of our solar system. Back in 2017, astronomers identified the asteroid Oumuamua as our solar system's first confirmed interstellar visitor. Its high speed and hyperbolic trajectory meant it couldn't have originated from within our solar system, and so must have come from beyond. However, it was already speeding out of the solar system by the time scientists worked out what it was. Then, in August last year, astronomers identified another interstellar visitor. This time it was a comet, 2I Borisov. It swooped round the Sun and made its closest approach in December, and is now heading back out to the darkness of interstellar space. Astronomers would love to study objects like these close up. But they're simply moving away so quickly, there's no time to put together and launch a mission in the small window of opportunity available before they're already gone. One way of reducing reaction times would be to have a constellation of tiny prepositioned solar-powered spacecraft ready to swoop in and intercept these interstellar vagabonds as soon as they're identified. The probes would use the Sun for a gravitational slingshot, flinging themselves towards their interstellar targets on close flybys, grabbing as much data as possible. Studying these interstellar objects would revolutionize science's understanding of planetary formation and evolution. And we think interstellar visitors to our solar system are actually quite common. It's just a question of identifying them quickly enough. This is SpaceTime. Still to come, new evidence for watery plumes erupting on the Jovian moon Europa. And NASA's Perseverance Rover placed in its launch configuration in preparation for its flight to Mars. All that and more still to come on SpaceTime. New computer simulations based on data from NASA's 1990s vintage Galileo spacecraft are providing more evidence that the Jovian ice moon Europa erupts plumes of water deep into space from its massive subsurface ocean. Scientists have long wanted to sample the oceans of Europa to see if there's anything living there, but getting to the European ocean's always been the big problem. After all, there's some 30 kilometers of solid ice harder than granite between the moon's surface and the liquid water. Having that water brought to the spacecraft instead of the spacecraft having to get to the water would make things a lot easier. Only slightly smaller than Earth's moon, Europa is one of Jupiter's 4 Galilean moons and the 6th largest moon in the solar system. Europa is thought to be tidally locked, with the same side always facing Jupiter, just like the same side of our moon always faces the Earth. Europa's crust is composed of water ice, frozen hard as bedrock, and striated by deep fractures, cracks, and shallower streaks. Europa has the smoothest surface of any known solid object in our solar system. Now, considering the amount of craters the other Jovian moons have, it suggests that Europa is being constantly resurfaced, probably by liquid water welling up from deep below and then freezing solid after it reaches the surface. Lining Europa's surface is a thin oxygen exosphere. Scientists estimate Europa's ice sheets average between 10 and 30 kilometers thick, and below that is a massive 100-kilometre deep subsurface global ocean, containing up to 3 times more water than all of Earth's oceans combined. At the base of its oceans is a thick silicate rocky mantle and then an iron-nickel core. Although it's well beyond the snowline where water usually freezes into ice, Europa's water is kept liquid through heating by tidal flexing and friction, as the 3,122-kilometre wide moon is constantly stretched and squeezed by the enormous gravitational pull of Jupiter, the solar system's largest planet. From 1995, NASA's Galileo spacecraft spent 8 years exploring the Jovian system, during which time it witnessed what appeared to be a geyser spewing liquid water and ice high above the surface of Europa. The new findings, reported in the journal Geophysical Research Letters, used computer simulations to reproduce the data gathered by Galileo's onboard particle detector. Scientists with the European Space Agency and the Max Planck Institute say the new simulations suggest that Europa does indeed occasionally eject liquid water and ice into space through cryovolcanic eruptions. Cryovolcanoes are quite common in the outer solar system. We've seen them on Neptune's moon Triton, Pluto's binary partner Charon, and of course Saturn's ice moon Enceladus, another world whose global subsurface oceans scientists want to explore for signs of life. In recent years, scientists have found independent evidence for cryovolcanic eruptions on Europa. This included data from Galileo's magnetometer, which during a flyby of Europa in the year 2000 measured deviations in Jupiter's magnetic field near the moon. Now, the hypothesis is that this was due to a plume of water that erupted from Europa at about the same time. Galileo's energetic particles detector was recording the distribution of high-energy protons trapped in Jupiter's magnetic field. The Jovian magnetic field's massive, up to 20 times stronger than Earth's magnetic field, and it extends for several million kilometres into space, well beyond the orbit of Europa. And during the flyby, Galileo recorded significantly fewer protons near Europa than expected. Now, previous researchers thought the moon may simply have been obstructing the detector's view. However, these new computer simulations are suggesting another possible cause. The simulations model the movements of high-energy protons trapped in the magnetic field during the flyby, reproducing the Galileo data. Now remember, protons are charged. They're simply the nucleus of hydrogen atoms. They found that when these protons collide with uncharged particles from the moon's exosphere or with water plumes, they incorporate electrons from the plumes or exosphere, causing them to lose their charge. And with no charge, they're no longer trapped by Jupiter's magnetic field, and so they leave the system, which perfectly explains the drop being seen in the Europa data. This is SpaceTime. Still to come, NASA's Perseverance Rover placed in launch configuration in preparation for its flight to Mars. And later in the science report, why men are suffering worse outcomes from infection with COVID-19 than women. All that and much more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, ExpressVPN, rated #1 by TechRadar. You may be wondering why you need a virtual private network. Well, it's in the name. It's all about privacy. Do you really want big brother tech companies, hackers, governments, and who knows who else snooping in on your online activities? Now, you might not have anything to hide, but it's still really creepy, and it could be dangerous for you and those you care about. Also, how often do you run across a website and you want to get information from it, but you find out that they're geo-blocked? It's all very frustrating, and it's becoming an increasing problem. And that's where ExpressVPN can help you. ExpressVPN's a simple and efficient way to protect your online privacy. It's internet without borders from the world's leading VPN provider. So, protect your online privacy today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more. And of course, you'll find the link details in the show notes and on our website. That's tryexpressvpn.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
NASA's scientists and engineers have placed the Mars 2020 Perseverance Rover into its final launch configuration in preparation for its ride to the Red Planet. The flight aboard an Atlas V rocket from Launch Complex 41 at the Cape Canaveral Air Force Station in Florida is slated for a 2-week launch window beginning on July the 17th. If all goes well, Perseverance will land in Jezero Crater just north of the Martian equator on February the 18th, 2021. Technicians at the Kennedy Space Center at Cape Canaveral have been carefully stacking the rover and other spacecraft components since late April, integrating the rover with its rocket-powered descent stage. One of the first steps in this operation involved lifting the descent stage onto Perseverance so that engineers could connect the two with explosive flight separation bolts. When it's time for the rover to touch down on Mars, these 3 bolts will be triggered to release by small pyrotechnic charges, and the spacecraft will execute its skycrane maneuver. Nylon cords will spill out through what are called bridle exit guides, lowering the rover some 7.6 meters below the descent stage. Once Perseverance senses its touchdown on the surface, pyrotechnically fired blades will sever the cords, and the descent stage will then fly off. The skycrane maneuver ensures Perseverance will land on the Martian surface free of any other spacecraft components, thereby eliminating the need for a complex deployment procedure. Attaching the rover to the descent stage is a major milestone for the mission because these are the first spacecraft components to come together for launch, and they'll be the last to separate when Perseverance finally reaches Mars. The 2 assemblies will remain firmly nestled together until they're about 20 meters above the red planet's surface. The day after the descent stage and rover were joined together, they were then attached to the cone-shaped back shell, which contains the parachute and, along with the mission's heat shield, provides protection for the rover and descent stage during the Martian atmospheric entry phase. Once on the Martian surface, Perseverance will begin its astrobiology mission, searching for signs of ancient microbial life. The rover will also characterize the planet's climate and geology, and it will collect samples for future return missions to Earth, and pave the way for human exploration of the red planet in the 2030s. Putting humans on Mars will be a very different task compared to going to the Moon. After all, the Moon's relatively nearby, a journey of just a couple of days. But going to Mars will mean a journey of about 7 months each way. And unless you're only staying for a day or so, which isn't going to happen, it'll mean an 18-month wait on the red planet's surface until the orbits of Earth and Mars line up again for the return journey. Logistically, NASA would like to see the fuel, water and oxygen needed on the red planet and for that return journey to be made on the red planet rather than being brought from Earth. Now, the rocket fuel can be made by simply splitting the water up into hydrogen and oxygen. But key to that, of course, is finding the water on Mars. And working out how to find water on Mars will be one of the missions undertaken by the Perseverance Rover. Scientists will use its high-resolution images to look for buried geology, such as ancient lake beds. Jezero Crater is unlikely to have any such deposits, but it will help prove the technology for eventual use elsewhere on Mars. And it will eventually be used to find stores of underground water ice, which the astronauts could access to provide drinking water. But of course, before people can start digging up water on Mars, they've got to get there safely, surviving both the radiation of the journey and the rigors of EDL, entry, descent and landing. And so NASA will use Perseverance's landing to determine how well the spacecraft's heat shield works and how the parachute performs in the thin Martian atmosphere. Perseverance will use its radar during descent to sense the approaching surface. Sensors on the spacecraft's aeroshell will study how it heats up and performs during atmospheric entry, helping to improve designs for bigger payloads, like astronaut equipment and habitats. Landing a 6-wheel car-sized rover like Perseverance and its earlier sister rover Curiosity provides engineers with valuable experience putting a heavy spacecraft on the surface of Mars, because the challenge of landing in the thin Martian atmosphere scales up with mass. Now, by comparison to Curiosity or Perseverance, the first manned spacecraft to Mars will be Titanic, carrying life support systems, supplies, and heaps of radiation shielding. Perseverance is also using a new, more advanced guidance system called terrain relative navigation that determines where the spacecraft's heading by taking images during the descent and then matching landmarks to a preloaded map. If the spacecraft drifts towards dangerous terrain during the landing, the terrain relative navigation system will divert it to a safer landing target. It was this system which allowed NASA to select the more risky, but scientifically far more interesting Jezero Crater as the preferred landing site, something simply not possible with the technology available 8 years earlier when Curiosity landed in nearby Gale Crater. This same kind of autonomous guidance system could prove essential for landing humans safely on Mars. It'll also be useful for landing equipment in the multiple drops needed ahead of a human crew. Perseverance is also carrying 5 samples of spacesuit material, 4 types of fabric and part of a helmet. It's all part of a science experiment called Sherlock, the scanning habitable environments with Raman and luminescence for organics and chemicals system. Yes, those acronyms are getting pretty tortured. Engineers will monitor the materials to see how they degrade over time, and that in turn will help design the spacesuits to shield the astronauts from long-term radiation as well as the Martian environment. Weather data gathered by Perseverance together with its sister rover Curiosity, as well as the Mars InSight lander, is also helping engineers develop the materials for the habitat modules, which will shelter the astronauts during their long stay on Mars. And of course, living on Mars will require a steady supply of oxygen, and that too will be costly to transport from Earth in the necessary volumes. One option would be to get it from the water, but another is to try and get it directly from the atmosphere. So a cube-shaped device called the Mars Oxygen In Situ Resource Utilization Experiment, or Moxie, is fitted to the rover to see how easily it converts carbon dioxide, which constitutes some 96% of the Martian atmosphere, into oxygen, as JPL mechanical engineer Mike Meacham and systems engineer Jim Lewis explain.
We've all seen The Martian, and we know we need breathable oxygen to survive on Mars. It turns out it's a lot better to be able to extract it from the atmosphere of Mars, then bring it with you on the trip over, if you have the technology. I'm here with Jim. He's going to teach us how to get oxygen on the surface of Mars. Jim, can you tell us where we are right now?
Absolutely. This is the JPL Mars Oxygen In Situ Resource Utilization Laboratory. We call this the Moxie Lab for short. The Moxie instrument is a demonstration mission designed to prove that we can produce pure oxygen on the surface of Mars. If it's successful, NASA may opt to send a dedicated mission to produce oxygen for humans to use in the future.
So how do we make oxygen on the surface of Mars?
It's actually a fairly easy process. Basically what we do is we take Mars atmosphere, we run it into a unit called a solid oxide electrolysis unit, which is basically a fuel cell in reverse.
Wait a second. Reverse fuel cell? How does that work?
So this is a solid oxide electrolysis unit. What happens is we have Mars atmosphere enter in this line, goes into the SOXY unit. It's then heated up to 800 degrees Celsius. We inject energy into the cathode and anode. And then what happens is oxygen is separated from the CO2 and comes out this line over here.
To test this technology, you're going to need some Martian atmosphere. Where on Earth are you going to find that?
We know the composition of Martian atmosphere. It's 95% CO2 with some trace gases. And there are companies here on Earth that will mix that gas for us. We call it Mars mixed gas, and we use it for most of our testing.
Well, what if we land on top of a mountain or down in a valley? The conditions for extracting oxygen are totally different. We've got to test for all of that.
So the way we test for it is we design an instrumentation system that covers all of the conditions of the instrument. Lower pressures, higher pressures, clogging filters, oxygen purity, all of that stuff.
Why don't we just bring the oxygen with us when we go to Mars?
It's very difficult to bring something from the surface of the Earth to the surface of Mars, and it costs millions and millions of dollars. So it's much easier and better for us if we try to get that resource from the planet.
And that report by NASA TV featured JPL mechanical engineer Mike Meacham and JPL systems engineer Jim Lewis. This is SpaceTime. Still to come, the science report, looking at why men are suffering worse outcomes from COVID-19 infection than women, and the US Space Force acquires its first offensive weapon. All that and much more still to come on SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Scientists might have finally worked out why men are suffering worse outcomes from infection with the COVID-19 novel coronavirus compared to women. A report in the European Heart Journal claims a large study of several thousand patients in 11 European countries shows that men have higher concentrations of angiostatin-converting enzyme, or ACE2, in their blood compared to women. ACE2 has already been shown to be a key COVID-19 receptor, with a virus found to target these cells in order to infect the body. With P2 and N95 face masks, which help protect against COVID-19 in short supply, people are being forced to wear the same mask for much longer than the 8 to 10 hours recommended by authorities. Now, one solution could be disinfecting the masks and then reusing them. But that presents its own problems, because cleaning them can break down the melt-blown polypropylene fibers which form a porous, breathable layer of the mask and which are electrostatically charged to capture the smaller virus particles which would otherwise slip through the holes. Now, a report in the journal ACS Nano has found heating the mask to 85 degrees Celsius for 20 minutes allowed the fabric to be treated 50 times without a loss of filtration efficiency. Now, by comparison, scientists found subjecting the filters to ultraviolet radiation allowed up to 20 cycles of disinfection. However, getting the exact UV dose needed to kill the virus without damaging the material is difficult. The authors found simply spraying the fabric with an ethanol or chlorine-based solution drastically reduced filtration efficiency after only one treatment, from around 96% down to 73% for bleach and just 56% for ethanol. And while a single steam treatment did maintain filtration, 5 steam treatments led to a sharp decline in efficiency. The use of methamphetamines, which is also commonly known by street names such as Goey, Speed and Crank, has skyrocketed over the past couple of decades. Despite its use in various forms such as crystal meth, often beginning among kids in their early teens, little is known about its effect on other drugs. While meth is known to accumulate in the liver, its influence on the metabolism of other drugs like caffeine and medicines is poorly understood. Now researchers have reported new work in the journal PLOS ONE showing exactly how meth altered various cellular pathways in the liver, which could in turn affect the metabolism of other drugs. The authors say the results also have clinical implications for female methamphetamine users of reproductive age. The United States Space Force has acquired its first offensive weapon, a ground-based counter-communication system designed to block satellite communications, rendering them useless. Counter-communication systems usually don't damage the satellites they target, but they do pose a major threat to military communications networks relying on satellites by jamming missile control and firing system signals and preventing messages from being relayed to troops deployed on missions. Conspiracy theorists in Australia and overseas have put on their tinfoil hats to protest about their latest theories on the COVID-19 coronavirus. Their targets were many and varied, ranging from 5G cell phone towers and government conspiracies to big pharmaceutical companies, secret societies, vaccinations, and even philanthropist and former Microsoft boss Bill Gates. Yet, ironically, the Chinese Communist government, which actually caused the pandemic in the first place, wasn't mentioned by the mostly fringe conspiracy groups. It all shows how easily people can become scared by things they don't understand. Or, more accurately in today's world, things they don't bother to take the time to try and understand. Tim Mendham from Australian Skeptic says the conspiracy theories simply aren't supported by the science.
5G is a variation on the electromagnetic frequency spectrum. It's below dangerous levels of ionising radiation, well below. You can probably get more danger from standing out in the sun too long than you're going to get from 5G. CSIRO deals with it very well, actually, in a little piece on busting COVID-19 myths. If you look up CSIRO scope and do a bit of COVID-19 myth searching, it talks about the 5G, and there's two aspects. Is that one, there is no mechanism by which 5G can spread a virus, because it's ephemeral radio wave. It can't sort of, whereas the virus is the physical thing. It can't do that. Also, it does not suppress your immune system. There's a number of studies have shown that exposure to radio waves are definitely within the safety standards, and they won't affect your health in the short term or the long term. And all of our telecommunications operations transmit within these safety standards, which are well known, well studied, and that as for this issue of suppressing your immune system, which crops up a lot amongst all the alternative cures, either to improve your immune system or the bad is suppress your immune system, there's no way it can. So it can't physically spread it, and there's no impact it would have on your immune system. But that doesn't stop people believing in it, and as happened in the UK recently, some people burnt down a telecom tower because it was supposedly transmitting 5G signals. So naturally, they want to protect themselves from coronavirus by burning down a tower. It sort of has rather sad images, doesn't it, of medieval times. That's exactly right. Burn the witch, and what they still do, actually, burn the messenger. Burning a tower is not going to do a lot to help.
I think people are getting ionising radiation mixed up with simple heating of things, and 5G is a part of the electromagnetic spectrum which doesn't do that. I mean, you can heat things with it. That's what microwave ovens are all about.
Yeah, I mean, the problem is the word radiation, right? People think radiation, they think sort of nuclear radiation, they think
cancer.
Nazis, yeah, whatever, and they think therefore for anything that mentions radiation, like the sun, is dangerous. And it's that perception, very quick jump to confusions about the terminology, in the same way as nuclear magnetic resonance imaging was changed to magnetic resonance imaging because no one liked the term nuclear, even though we all have nucleus in us. But I mean, it's a word thing as much as anything else.
This comes back to understanding the science, doesn't it?
It does, very much understand the science, because science is hard. It's technical. It's all those things, and sort of for the ordinary person, without being imputing their intelligence and everything, it's hard. It's difficult to understand, and fair enough. That's why you have scientists. That's why we're not all scientists, because it is difficult when you talk about quantum physics and all sorts of areas like that. But people then raise buzzwords like quantum physics in their alternative treatments and philosophies without really understanding what the science is. So if you try and explain electromagnetic radiation and frequencies and that sort of stuff, people sort of go and turn off. Science is hard to explain, and trying to find a scientist who can explain clearly is very difficult. There's a very, very, very small percentage of scientists, from my experience, who can actually talk in lay terms.
This gives me an income, you understand.
Well, that's right. I mean, you do talk science and you explain science to people who are not necessarily astronomers or whatever, and that's what it's all about. I mean, David Attenborough has a bit of a science background. He's not heavy science, but he's got a science background. He can explain science. He's been doing it for long enough that he's got a lot of practice at it. But I've seen scientists who I would not put in touch with the public because they cannot talk people, and therefore trying to encourage people to understand everything from electromagnetic radiation and 5G to how vaccines work and all those sort of areas. It's hard because most scientists scare people off because they suddenly talk tech because they feel everyone should know it, and they don't. Talk to IT people who talk tech, talk to any sort of technical subject, and they'll soon start talking in their
well, most people
jargon.
have their own specialities, don't they? And
that's right.
Once they get into their rhythm,
if you don't understand, that's your fault, whereas it's not. It's the communicator's fault. It's the communicator's job to explain how things work, not the subject's responsibility to understand.
What I found with one particular tough friend of mine, he's absolutely certain that you get radiation from cell phones, and that at the same time he also believes that there's no such thing as climate change. It's all part of a government conspiracy. And the only way I can convince him was not by talking about those things, but by going on a completely different tangent and talking about what peer review is all about in science, how that works. And once I explained that to him, then I could ask him, well, this stuff you've read on global warming, who peer reviewed it? How many articles did you read, and how much of it was peer reviewed? Then there was this long silence, and I think at that moment he realized that maybe his sources aren't necessarily, because he'd already accepted that peer review is the way to go. And so once he had to put his new standards on that, they actually helped.
It's a funny old world.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.